So here we are, third video, and again we're in the same section here, 2.1 part 3. Just an application problem here. We've got a rock falling from a height of 20 meters on Jupiter, something you've probably always wanted to know. And its height after height h in meters after x seconds is what you see here. So what I'm going to have you do is get your calculator ready, and if you don't have that ready, then go ahead and pause the video. The calculator, we're going to actually go to the y equals, and if by chance, let's go back to this part here where you hit the mode button, and when you hit the mode button, I'm not really enjoying the lighting here. My apologies. I'm going to have to fix this for the next time I do a calculator video. But make sure that you're in radian mode. Function mode. Radian mode really doesn't matter right now, but function mode. All right, so that when I push the y equals, I get that screen. So we want y equals. And let's go ahead and, as we noticed here, that the h of x, well, that's what we're going to call our y1. Okay, so when we're dealing with functions like this, and we're using our calculator, we want to go ahead and name our h of x, whatever our function's name is, we're going to change it to y1. Okay, so we can easily find some important information about the function. So we have 20 minus 13x squared is our function, and what we're trying to do here is we're trying to find the height when x equals 1. Now, I do realize that you can do this one in your head. When x equals 1, you have 20 minus 13, so that's 7. So the height after 1 second is 7 meters. Okay, so if you look at the problem, just to get an idea, you've got a rock up on Jupiter, and someone standing, up on Jupiter, as if that could happen. So you've got right up here, let's say that's the 20 meter mark. Okay, so let's draw a line all the way down like that. Here is 0 meters, and right up here is 20 meters. Okay, and so at the 20 meter mark, someone drops a rock. Okay, they drop a rock 1 second later. If that's 10, then right here, 7 meters, that's at t equals 1 second. So just to get a visual of what's going on, that hopefully helps you understand. So you're dropping a rock, it's going straight down like this, and the time starts ticking as soon as you drop the rock, and 1 second later it's at the 7 meter mark. Okay, so then what we want to find out is what's the height at 1.1 second. Well, let's use our calculator to help us out, because it's important you're able to actually figure this out with your calculator. And notice that y1 is a function of x. Okay, so y1 is a function of x, just like here, your y1 we let the h of x equal to y1. So if y1 is a function of x, and so most students don't know how to do this yet until they get to pre-calc honors, so I'm going to teach you right now. What we want to know is what h of 1.1 is. Okay, and I keep going back and forth, my apologies, but h of 1.1, if we look at we already know that h of 1 is 20 minus 13 times 1 squared, which is equal to 20 minus 13, which is 7. We just talked about that. But h of 1.1, we're going to use our calculator for this part, and h of 1.1 is y1 of 1.1. Okay, and then we're going to put the little approximately equal to, because I'm pretty sure we're going to get a decimal answer. But let's take a look and see how this works on our calculator. To get to the y1, you want to access the y1 function. There's a vars button right there. Okay, so you can see my pen pointing at it. The vars button is just to the left of the clear button. Push that button, and when you push that button, you get this window. Okay, we've already defined h of x to be the y1. So notice that you have vars and you have y vars. The y variables, use your right arrow. It's the one you see my finger pushing right now, the right arrow, and then you get y variables. Okay, well, we talked about being in function mode, so we want to push the enter key now, because you can see here that function mode is already selected. So when you push the enter key, you get a selection of all the different y functions. And again, we've already defined h of x to be the y1, so we're going to hit enter. by the way, all that stuff that we just talked about that took about a minute to explain, that takes about 5 seconds to do when you understand what to do. So we want y1 at, and then we're going to plug in a 1.1 and close the parentheses. You don't need to close them, but it's a good habit to be in. Enter, and we get 4.27. Okay, so that's actually equal to 4.27, so we don't need the approximate equal symbols. So we are going to change that to an equal, so I'll wait next time to do that. So we get 4.27, and then I should put meters there. Okay, and then we're going to do the same. Why don't you pause the video and do the same for your your height at 1.2 seconds. Okay, so the height at 1.2 seconds. Go ahead and pause the video. By the way, here's a little trick for you. If you want to use that same function, do second, and then down here lower right is the enter button. But when you hit the second key first, notice that the word entry is just above the enter key. Well, second entry, when you push that, means that you can actually edit what you just input. It means that you can use your left arrow, and instead of using 1.1, we can use 1.2 and then enter, and then we get 1.28. So that's a little trick that is very handy, and we can just write that in right here, 1.28 meters. And so we see that the height of the rock is getting lower, so that's a good thing because it means that we're probably doing things right. So that takes care of part A. All right, let's look at part B. How can we do this? All right, so part B, the solution for part B, again, we're running out of room. When is the height 15 meters? Well, when is y, that's what we're asking, when is y1 equal to 15? We want to know the x now. Okay, so here's a little trick for you. If we want to know the x when y1 is 15, then we have to solve, keep going back and forth, we want to solve this equation. 15 equals 20 minus 13x squared. Okay, so you got to solve that because we'll be able to find the x when the y is 15. And so if we bring the 13x squared over to this side and we bring the 15 over to this side, then we divide both sides by 13, we get x squared equals 5 over 13. So we get that when x is equal to this positive square root. Now, having a negative number for x doesn't really make any sense because x represents time. Okay, so x is equal to the square root of 5 over 13, and let's see what that is. Second square root, 5 divided by 13, and we get 0.6201. So we're going to round to the nearest 3 digits after the decimal, so let's round that to 0.62. Okay, 0.62 what? Pause the video if you don't know. 0.62 seconds. Okay, and so when is y1, when is the height equal to 15 meters? Well, that's at the 0.62 second mark. And that makes sense because it was 1 second to get down to 7 meters, and at the 15 meter mark it's 0.62. All right, and then the 10 meter mark, okay, the 10 meter mark, we just want to let y1 equal 10, and y1 equals 10. Got a little bit of space over here. Maybe I'll change colors so that you can easily see it. So you solve the equation 10 equals 20 minus 13x squared. Okay, and then so we're going to solve it right here. 13x squared is equal to 10. X equals the square root of 10 over 13. I'm shaving steps here to save a little space. But again, if we want to do second entry again, we can do the square root of, and then second insert 10 and delete that 5, and we get the square root of 10 over 13, and we get 0.877. Okay, so that's the 0.877 mark. 0.877 seconds. And then if we use a little logic here, if we put a 5 there, then we're going to have a 15 there, so we're going to have a 13, so we're going to change that. So this guy here, let's do that in yet another color. I thought I had green, there it is. So we're going to do this in green down here. When 5 equals 20 minus 13x squared, when is that going to happen? It's when 13x squared equals 15, and when x equals the square root of 15 over 13, which is equal to about, and try that little trick again, second entry, then we can change that 0 to a 5, 15 over 13, and we get 1.074 seconds. So 1.074 seconds. And when does the rock hit the ground? Well, what does that mean? When does the rock hit the ground? What's the height? Try to answer that. Try to answer that before I get there. Come on, you can do it. When does the rock hit the ground? What has to be true? We've got a variable. We've got a height and we've got a time. Well, what's the height when the when the rock hits the ground? The height is 0. So 0 equals 20 minus 13x squared. That means when 13x squared equals 20, or when x equals the square root of 20 over 13, which is about, let's see if we can do that little trick again, second entry, right over here, 20 over 13, and we get 1.240 seconds. So we're going to just write 1.24 seconds. And that is it. Okay. And I think that it would be a great idea for you to do a couple problems here, and then we'll talk about those in class. Okay. So what we're going to do is this. I'm going to have you do, where's my paper? Okay. So you're going to do 3 problems, and these 3 problems, I may or may not do videos for these, depending. Depending on my time. But I want you to do these 3 problems as practice problems for before you come to class on whatever day you're going to have class. Okay. So these are the lesson recap problems. So one from each. Find the domain, evaluate the difference quotient for this function, and then do an application problem. So you did my lesson, you did the practice problems, and then here's some 3 basically like homework problems, just to give you start to finish 3 different kinds of problems that we did during the lesson. So I will see you in class, and have a great night.